In this video, we're going to continue our discussion of database transaction, and we're going to look at some concurrency issues that can arise. So previously we talked about grouping little things you can do in a database, updating various fields of various records, and said that the idea of a transaction was that these little actions should be grouped into something that should be considered a unit and not sort of and like an all or nothing unit, and that this would be a transaction, and that a transaction should pass what we call the acid test, where acid is an acronym. The A stands for atomic, C consistent, I isolated, and D durable. So the atomic means think of it as a unit. The C, move it from one consistent state to another. Isolated means that two transactions don't interfere with each other in any way. And durable means once committed, the transaction should be like stored, remembered, be recoverable if something were to go wrong. And we're going to focus here on sort of isolation issues, sort of what if there's, multiple transactions going on, what problems can arise that, make then sort of fail the I in the acid test, the sort of non-isolation. Okay. All right. So people always pay a little bit more attention when it means money. So let's have some transactions that involve like a bank account. So we're going to have a database that's corresponding to money in a bank, and so we want to update somebody's account. So we're going to find their balance and then maybe add or subtract some kind of deposit or withdrawal, and then write in the new amount. So we're going to get the balance. That will be mainly a select, and then we're going to do some kind of add a deposit or something like that. That will be some kind of updating in database language. Okay. And now let's try to talk about some transactions that have multiple steps. So they take some time to complete. And what if two transactions are sort of happening at the same time? So let's suppose that there are two transactions trying to put money into the same account. So that seems like a good thing. So I don't know, maybe your grandmother's trying to put some money in your account and you're trying to put some money in your account. So you begin your transaction one, and you get your balance, and grandma at the same time, she is accessing your account. So that was sort of the second line there, get balance in transaction two. And then you deposit your $100. So you started off with 500, now you're up to 600. And then your grandmother adds the 50, and we've lost that 100 that you put in because she access the balance before you made your deposit of 100. So that second transaction is not seeing the 100. And then when the 50 is added, that 100 is lost. So this is clearly a problem. These two transactions are not isolated. What about that's if the two transactions go through? We also have problems when transactions fail. So let's look at these two transactions of putting in $100 and putting in $50, but one of the transactions, the first one, for some reason fails and has to be rolled back. So we're getting the balance of the first account. So that's 500. And then we have added the deposit of the $100. So now we're reading 600. And then something went wrong. I don't know, the $100 was a counterfeit or something like that. But in the meantime, transaction two gets the balance and sees it as 600. And the first transaction with the counterfeit money or what have you has to be rolled back, putting us back at 500. but the second transaction started and got the balance at 600 and added $50 and shows up as 650. Okay, so again, whether transaction succeeds or fails, two transactions can interfere with each other, especially if there's both reading and writing of the same data. Okay, let's just do have one transaction, um, just doing like some accounting, not really changing anything, just sort of getting an analysis. So transaction one is just, the person has two accounts and we're finding out how much money that person has altogether. So just some simple coding, start the sum at zero, add balance one, add balance two. But another transaction's going on where we are like adding the $50. Okay. So now the analysis, so there were the two accounts with 500 and 100. Um, and we're doing the analysis, and then uh, the 50 is coming in while the analysis is being done. Okay. And then, so then the analysis doesn't, uh, reflect the 50. So it's all right to do the analysis before the transaction. Like analysis probably will have something like a timestamp. At this time, this was the amount in the two counts. So if the transaction one is completed before the deposit, that's okay. It'll be time stamped. You know that the analysis was done before the deposit and doesn't reflect the deposit. On the other hand, the transaction can be done after the deposit, and then the timestamp will again recognize that. But if the two are going on simultaneously, then it's unclear that the analysis, the summing of what's in the accounts and the deposit, if those transactions are happening at the same time, then it's not clear the the analysis is of anything that was ever the consistent state of the person's accounts. Okay. So the simplest way is to just do everything serially, like have transactions, all their steps, keep them atomic, and just do one and then do the next one in serial, all the steps. Um, so we're only sort of doing one transaction at a time. Um, that will keep things consistent. So the transactions are designed to move us from consistent state to consistent state. And if we're only ever doing one transaction at a time, then each time the transaction is completed or not or rolled back, we are back in a consistent state. Um, that keeps us consistent, but um, it's not always possible, or not, that's not possible, but not convenient, not efficient. Um, so we have to worry about like the order of things matters. Like in that previous example, the when you're doing interest and when you're depositing or when you're doing some analysis and depositing or taking money out, withdrawing. Those all, of course, matter, but what we're concerned about is sort of the consistency. Is it consistent? Okay. And serialization will keep it consistent, but there's a problems that there's vast amounts of data. Imagine you went on Amazon and you couldn't get your order because somebody else started an order and didn't finish their order. So now all your orders got to wait for, somebody else's order. I mean, and it's unnecessary. Um, if if we're not dealing with the same data, then there won't be interference. So there are times when you're just reading data, that's not a problem. There are times when you're updating, you're changing some data, but if it's completely different data, it's not going to interfere. So that's what we want to be able to separate. When are transactions uh, independent, so that it doesn't matter whether we serialize them or not? And then which ones sort of need to be need a little more care, and we need to sort of like stop one and wait until the other one is finished. Sort of how do we make that distinction, and what measures do we put in place to make sure that they don't interfere? But right now we're just focusing on the problem, seeing what kind of problems can occur. So again, what can we allow? What shouldn't we allow? If we're just reading data, it doesn't matter. So, somebody can read over my shoulder. It doesn't interfere. It may be annoying, but it doesn't interfere with the data. They see the data. I see the data. We're both allowed to see the data. There's no interference. Um, if we are reading and writing but completely separate, like my account and your account have nothing to do with each other. So, unless you're moving money into my account, but if I'm doing withdrawing from my account and you're depositing in your account, and not moving funds from one to the other, but just two completely separate transactions, they are fine. It's when there's reading and writing of the same data, then we've got the problem. So this is some data, some transactions that are serializable, that can be uh, put in that all of one transaction happens and then the all of the other transaction happens, and there's no interference even though they involve some reading and writing. So here, this transaction 7 is looking at balance X. So it's reading balance X and then writing it. And then at that stage, transaction 8 comes in and it's going to do something with X, read it and then write it, some change to the balance. But it's seeing what transaction 7 had already done. And transaction 7 was done with balance X. So it's not going to change the value of balance X after transaction 8 reads it. So we're okay here. And then transaction 7 does something to Y, and then it is done before transaction 8 has anything to do with Y. And so, because transaction 7 is done with balance X by the time balance 8 comes in, we can think of that as all just move 8 to happening completely after 7 is done. And so we say that this particular transaction is serializable. It has the same effect as if there's transaction 7 and it's done, and then transaction 8. So if two transactions are serializable, that means they have the same effect as if they were done completely in serial. Okay. Now let's imagine here's something that's not serializable. So the person has two accounts, X and Y, and they're going to move money from one account to the other. And then the bank is also calculating interest. So that multiplied by 1.1, that's 10%. That's a good amount of interest, but that's calculating interest. So we're getting a new, so 10 is figuring out the interest owed to the accounts because they're keeping the money in the bank or what have you. And transaction 9 is taking money from one account to the other. So we added some money to the account in 9, up in step 3 up there, and wrote the new amount in step 4, and then uh, the calculated interest comes in. So we're calculating the interest of balance X and balance Y, and then we're taking that $100 out of the Y account of the person. And so when the interest was calculated, there was an extra $100 in sort of combined accounts. So we're not if we're looking at the sum of what's in account X and account Y, it's not changing because we're adding 100 to one and subtracting 100 from the other. But during the time at which the interest calculating and paying the interest was done, there seems to be an extra $100 in the account. So this is not serializable. This the you can of course you can pay the interest and then change the money in the account, or you can change the money in the account and then do the interest. But the way it's being done here, with one transaction started and then the interest calculation and then finishing it, is sort of not correct, not consistent, not consistent with those transactions being serialized. So we want to go from consistent state to consistent state. These two transactions are not taking us into a consistent state. Transaction 9 can happen before 10, or vice versa. 10 can happen before 9, strictly speaking, although the numbers suggest that 9 happens first. But this should not happen. This is not consistent. And it's just me sort of explaining that, which I just said, the, the moving money from one account to the other. But if it's not complete, there seems to be more money than there is between the two accounts. And so when one pays the interest, one's paying an extra amount of interest. So this would be bad on the bank's account. And it would also be bad on the bank's part if they took the money out first, because then they would be cheating somebody. So there we are. We're just talking about problems with transactions. What kind of transactions cause problems? It'll be the next video where we will try to look at some of the measures we put in place to stop such problems from happening. How do we stop a transaction that will interfere and lead to an inconsistent state? That's it for this one. Thanks for your attention.